This is the question that we are given, and we have to prove that this is less than 2. Come to think of it, as a mathematician, as a learner, so how come adding this number together, we are not to write everything, but with this pattern that we are given here, so it's less than 2. So when you think about this, you'll be amazed. And that is what mathematics entails. You get to a point in time that you are going to be amazed at how come, how possible. So now let's prove it together. So we need to figure out the pattern. And when you have this, there must be a pattern. Whenever you are given this type of question, you must figure out the pattern. So if you are able to figure out the pattern, then there's a way. But if you are unable to figure out the pattern, there's nothing you can do. Because the first step that must be taken here is you need to figure out what pattern this series, because it's a series, because there's addition, volume. So now we have, let's say we have 2, let's multiply by 2, and at the same time we divide by 2. When you multiply by 2 and you divide by 2, you are going to have 1. So 2 over 2 is 1. And whenever this is multiplied with any number, you are going to have that number. That is, we have 2, 3 plus 1 over 6 plus 1 over 10 plus 1 over 15 plus 1 over 21 plus, then everything here less than 2. So now you know that I said earlier that, so if you get to a point mathematics that you'll be amazed. Now we multiply by 2. 2 over 2 is 1. And whenever number is multiplied by 1, you are going to have that number. So we are going to multiply by 2, then at the same time we divide by 2, which is equal to 1. That means we are multiplying this series here by 1, which will not change anything. So we are going to multiply by 2 and we divide by 2. Then 2 by 1 is 2, then over 2. Plus 2 by 1, we have 2, 2 times 3, 6, 2 by 6. Then 2 by 1 is 2, 2 by 6 we have 12, 2 by 1 we have 2, 2 by 10 we have 20, 2 by 1 we have 2, 2 by 15 we have 30. So 2 by 1 we have 2, 2 by 21 we have 42. So plus, so less than 2. Now in this case, you can see that 2 is common. So let's take out this 2. So that if we are going to factorize this 2 out, because it's common to the numerator. When you factorize 2 out, then you are going to have 1 over 2. Then in this case here, so this 2 has been factorized, we have plus 1. Then 6 can be written as 2 dot times 3. That dot is multiplication. Then plus, this has been factorized, we have 1 over. This 12 can be written as 3 times 4. Plus this one, we have 1 divided by 20, can be written as 4 times 5. Plus 2 factorized 2 out here, you have 1 divided by, then we have 5 times 6. Plus factorized 2 out here, you have 1, then we have 6 times 7. This is the pattern. So we have this. Now in this case, this is a 10, and we want to generalize it for the end 10. So we are using letter to generalize the 10, because we must generalize it in order to prove this. This will can be written as 2, that is 1 times 2. So when you consider the first numbers, 1, 2, 3, 4, 5, 6. So that is, we have 1, 2, 3, 4, 5, and 6. These are natural numbers. They are counting of numbers in primary school, 1, 2, 3, 4. So they are natural numbers. Now we have 1, 2, 3, 4, 5, 6. Then we want to analyze the end for the end start using AP. Here the common difference, D is 2 minus 1. So in this case, we have the formula for AP, that is A plus N minus 1 multiplied by D. So therefore A is 1. 1 plus N, we are generalizing it for N time. So minus 1. Common difference is 2 minus 1, 1. So we have, when you multiply, we have 1 plus N, then minus 1. This one we cancel it. Therefore for this we have N. So when N equals to 1, N equals to 3, 4, then we are going to write N. Now the next terms that we are going to consider, we have 2, 3, 4, 5, 6, 7. Now the first term here is A equals to 2. Common difference, D equals to 3 minus, that is second term minus first term. So using this formula, we have 1. A equals to 2. So we are going to apply this one now. We have 2 plus N minus 1, then multiply by 1. So we have 2 plus, when you open the bracket with 1, 1 by n will give us n, 1 by 1 will give us 1. So 2 minus 1 is 1. So therefore we have n plus 1. Now for the second numbers in each term, so we are using n plus 1. So that is 1 plus 1 will give us 2. Now we have 2 multiplied by 1 plus 2 plus 1 over 2 multiplied by 3 plus 1 over 3 multiplied by 4 plus 1 over 4 multiplied by 5 plus 1 over 5 multiplied by 6 plus 1 over 6 multiplied by 7 plus. Then the last time, we want to write the last time using the pattern that we have for the nth term now. So that this will be the last time, that is we have 1 over n, that is n equals to 1, n equals to 2. Then for 2, that is this one will now be 1 plus, that is n plus 1. When n equals to 1 plus 1, 2. When n equals to 2 plus 1, 3, that will be n plus 1. Then less than 2. Let's equate this to the sum of n. That is the sum of n equals to this. So we have s of n equals to, then we are going to write this one. We expect this term, the pattern here, as a partial fraction. We are going to express as a partial fraction. So now to express this number as a partial fraction, we have, let's do it here. We have 1 over n into n plus 1. So equals to partial fraction, we have a over n, so plus b over n plus 1. For you to understand this, you must have knowledge of partial fraction. So if you don't have knowledge of partial fraction, you will not be able to understand this. So, but with good knowledge of partial fraction, you are going to understand this. Now, here when you find the SM of this, you are going to have n into n plus 1. Then n goes here, that will be n plus 1. Multiplied by a, we have a into n plus 1. Then n plus 1 goes here, we have n. Multiplied by b, we have b times n. Now, by the time we use cover up, we are going to cover up rule. What do we mean by cover up rule? We have n equals to 0, that's cover up, or n plus 1 equal to 0. So that is we have n equals to minus 1. So when we substitute, that is we have a into n plus 1 plus bn. So that is the denominator are equal. Then numerator 2 are also equal. That is a on this side, we have a bracket n plus 1 plus bn as the numerator equals to 1. On the other side here equals to 1. Then when n equals to 0, substitute 0 in place of n, 0 plus 1 plus b into 0 equals to 1. So here, b by 0 will give us 0. Then 0 plus 1, 1 times a will give us 0. Therefore, a equals to 1. And when n equals to minus 1, we substitute minus 1 into this equation. So that this is when n equals to, that is, n equals to 0. Then we want to use n equals to minus 1. So in place of n, we use minus 1 plus 1, then plus b into minus 1. This is when n equals to minus 1. That is n equals to minus 1. When you simplify, minus 1 plus 1 is 0. 0 by this we cancel. Then minus b, that is minus 1 times b will give us minus b equals 1, which implies b equals to minus 1. B equals to minus 1. So this as a partial fraction can be written as, so we have this. That is we have 2 into, we have 1 over 1 dot 2, then plus 1 over 2 dot 3 plus 1 over 3 dot 4 plus 1 over 4 dot 5 plus 1 over 5 dot 6 plus 1 over 6 dot 7 plus. Now when you express this as a partial fraction, you are going to have, if you are adding it together, you are going to have 1 over n. Then will be minus now. So when you substitute here, this, that is we have n, that is 1 over n into n plus 1 will be equals a is 1. So we have 1 over n, then minus b, since b is minus 1. So we have minus 1, then divided by n plus 1. That means in place of this, written as a partial fraction, we can write this one there. So we have 1 over n plus 1. That is the meaning. Less than, that is less than 2. So therefore, in this case, when you simplify this, what we have here, you are going to have the same thing, nothing will change. So therefore, we have s of n equals to 2 multiplied by. So we are going to follow, then this will be written in this form. So that is we have 1 over, so then this n is 1, then minus 1 over, then that is how to rewrite this one. We are expressing this as a partial fraction, this also as a partial fraction, this as a partial fraction, which will lead to 1 over 1 plus then n plus 1. That will be 1 plus 1, that will be 2. We have 1 over 2, then plus. So for the next time now, when n equals 2, we have 1 over 2, then minus 1 over 2 plus 1 will give us 3. Now plus when n equals to 3, we have 1 over 3. Now minus 1 over 3 plus 1, that will be 4. Plus, then when n equals to 4, we have 1 over 4 minus then 4 plus 1, that will be 5. Then plus, then when you continue, you are going to arrive at this. That is, you have 1 over n, which will be the last term, second to the last, rather, minus 1 over n plus 1. So less than 2. So therefore, in this case, you can look at the quadrant, this, we cancel this. So minus 1 over 3 plus 1 over 3 cancel. Minus 1 over 4 plus 1 over 4 cancel. Minus 1 over 5, the next time will be plus 1 over 5. Now, the previous term before 1 over n will be minus 1 over n, which will cancel this. So the previous term will be minus 1 over n. And to cancel this one, you have this one. This will be the leading term, which is 1 over 1. Then we have the last term, which is minus 1 over n plus 1. So therefore, we have s of n equals 2 multiplied by 1. Then 1 divided by 1 is 1 minus 1 over n plus 1. Because every other term, we cancel out. So then we have this. So less than 2. So therefore, we have 2. Let's evaluate this one or simplify this one. We are going to we have n plus 1. This goes here, that's n plus 1. 1 goes here, n plus 1 times multiplied by this, that will be n plus 1. Then minus this goes here, 1 multiplied by this, we have 1 time. So less than 2. So in this case, we have 2 to bracket this, we cancel this, we have n over n plus 1. Then less than 2. So therefore, from here, since n, the same n that we have in the numerator is the same thing as this, which we can be written that n is less than n plus 1. If n is less than n plus 1, therefore n over n plus 1 is less than 1. So if you are multiplying number less than 1 by 2, you can only multiply 2 by 1 to get 2. Then if you are multiplying number less than 1 by 2, you are going to have a number less than 1. This is what we are required to prove. So therefore, we have come to the end of the which what we are having here. So it shows that this, so from the given patterns there, so is less than 2. Please like, comment, and share.